You ever just stop and think about the absolute magic that's happening inside your phone every time you pull up a map? I mean, we use it every single day, but how does it actually work? Well, today, we're going to pull back the curtain and unpack the incredible science behind the Global Positioning System, or GPS. So yeah, here's the big question, right? How in the world does this little device in your hand know exactly where you are on this massive spinning rock we call Earth? The answer, and I promise you this, is way cooler than you probably think. Because what you've got is this wild mix of some pretty fundamental ideas. We're talking basic 3D geometry, clocks so precise they boggle the mind, and believe it or not, a huge assist from Albert Einstein's theory of relativity. It's an amazing story. Okay, so let's start with puzzle number one, the basic geometry of it all. The whole system is built on a really clever idea called trilateration. And basically, it's all about using distances to zero in on a specific spot. So imagine your phone gets a signal from one satellite way up in space. That satellite basically says, hey, you are exactly 20,000 kilometers away from me. Now that's useful, but not that useful, because you could be anywhere on the surface of a giant imaginary sphere that has that satellite at its very center. Right, but now let's add a second satellite to the mix. Your phone gets another distance reading, which creates a second giant sphere. Now think about it. The only place you can possibly be is where those two spheres overlap. And the intersection of two spheres? It's a perfect circle. Okay, we're getting warmer. And the last piece of this geometry puzzle is, you guessed it, a third satellite. The sphere from this third satellite cuts through that circle at just 2 points. So, which one are you? Well, usually one of those points is like thousands of miles out in space, and the other is right here on Earth. Your phone is smart enough to know you're not an astronaut, so it throws out the impossible answer. And bam! What's left is your exact location. That's trilateration. Okay, so that geometry is pretty neat, but it's totally useless if we can't solve puzzle number two. How does your phone know how far away it is from those satellites to begin with? Well, the answer involves a race against the fastest thing in the universe, the speed of light. It all comes down to this super simple but really powerful formula. See, every GPS satellite is constantly beaming down a radio signal, and packed inside that signal is two crucial bits of info: the satellite's exact position in orbit and the super precise time the signal was sent. And since we know that radio waves travel at the speed of light, which is a constant, your phone just has to time how long it took for the signal to get there, and boom, it can calculate the distance. Now, this is where things get absolutely insane, because the speed of light is so incredibly fast, about 300,000 kilometers every second, the tiniest little error in timing has massive consequences. If your phone's time measurement is off by just 1 millionth of a second, a single microsecond, your calculated location will be off by 300 meters. That's 3 football fields. The precision required is just staggering. And that leads us straight to puzzle number 3, which honestly feels like a total deal breaker. How do we get that kind of microsecond precision when the clock in your phone is, let's be honest, pretty terrible? I mean, just look at this. It's night and day. The satellites are carrying these $100,000 atomic clocks that are accurate to within nanoseconds. Meanwhile, your phone has a cheap little quartz clock that costs less than $1 and is constantly drifting. There's just no way it can measure time accurately enough. So how on earth does the system work? Okay, here is the absolutely brilliant solution. Your phone's clock might be wrong, but it's consistently wrong. Its time error, or offset, is the exact same for every satellite signal it picks up. So the engineers treated that time error as a fourth unknown variable. You've got your 3 unknowns in space, X, Y, and Z, and now a fourth unknown, time. And if you remember your high school algebra, to solve for 4 unknowns, you need 4 equations. And that means you need a signal from a fourth satellite. So your phone needs to see at least 4 satellites, not just to find where you are, but to fix its own broken clock at the same time. Genius. But wait, it gets even weirder. Even with that clever math trick, there's one last, totally mind-bending puzzle to solve. It turns out that even if every clock was perfectly in sync, time itself doesn't tick at the same rate everywhere in the universe. And to make GPS work, we have to call in the big guns, Albert Einstein. I just love this quote because it's so incredibly true. This isn't just some dusty old theory in a textbook. Every single time you use Google Maps to find the nearest coffee shop, you are directly using one of the most profound scientific discoveries in all of human history. It's amazing. So there are actually two of Einstein's theories at play here, and they pull in opposite directions. First, you've got special relativity. It says that the faster you move, the slower time ticks. The satellites are zooming around the Earth at 14,000 kilometers an hour, so their clocks actually run a little slow, by about 7 microseconds every day. But then, general relativity comes along and says that gravity warps time. The weaker the gravity, the faster time ticks. And since the satellites are way up high in weaker gravity, their clocks speed up by about 45 microseconds a day. So you've got one effect slowing time down and a bigger effect speeding it up. You do the math, and the net result is that every satellite's clock gains about 38 microseconds on us down here on Earth every single day. Now that doesn't sound like much, right? 38 millionths of a second. But as we already know, with GPS, tiny bits of time are a huge deal. And get this is the critical part. If the engineers who built GPS didn't program in corrections for Einstein's relativity, the whole system would accumulate errors of about 10 kilometers every single day. Within a couple of hours, it would be completely useless for navigation. Let that sink in. GPS literally could not work without the theory of relativity. So now that we've cracked all the physics and math puzzles, let's just zoom out for a second and appreciate the incredible global machine that makes this whole thing possible every second of every day. The entire system is really made of three big parts. You've got the space segment. That's the constellation of 32 satellites orbiting way up there. Then there's the control segment. This is a network of ground stations all over the globe that are constantly tracking the satellites, making tiny tweaks to their orbits, and crucially, making sure their atomic clocks are perfectly synced up. And finally, there's the user segment. That's just, well, it's us. It's the billions of little GPS receivers in our phones, our cars, and our watches that are constantly listening for these faint signals from space and doing all of those incredible calculations we just talked about. And here's one last thought to leave you with. It's easy to think of GPS as just being for maps and location, but that's not even half the story. That unbelievably precise timing signal from the satellite's atomic clocks is the invisible heartbeat that synchronizes global banking systems, power grids, and even cellular networks. So the next time you check your location on your phone, just take a second to appreciate this incredible invisible symphony of satellites, atomic clocks, and Einstein's brain-bending physics that makes our modern world tick. It really makes you wonder, doesn't it? What other invisible magic is quietly holding our world together?